Hello everyone, welcome to today's class. Today, we will deeply explore three common types of valves: gate valves, globe valves, and ball valves. We will learn their structures, working principles, and characteristics. First, let's talk about gate valves. Gate valves are widely used in various pipeline systems. Structurally, gate valves mainly consist of a valve body, valve cover, gate, valve stem, sealing setting, and other parts. The valve body is the shell of the valve. It supports and connects the pipeline. The valve cover is connected to the valve body. It protects internal components like the valve stem and gate. The gate is the core opening and closing component of the valve. Its shape is usually flat, or sometimes wedge-shaped. The valve stem controls the up and down of the gate through a threaded connection with the gate. It enables the up and down movement of the gate. The sealing setting ensures the sealing of the valve when closed, preventing fluid leakage. The working principle of gate valves is relatively simple. When we rotate the valve stem clockwise, the valve stem drives the gate downward until the gate completely closes the fluid access. At this point, the valve is closed. Conversely, rotating the valve stem counterclockwise, the gate moves upward. The fluid access gradually opens, and the valve opens. The characteristics of gate valves are quite significant. Its main advantage is low flow resistance. The pressure drop when medium passes through is small, and it has significant energy-saving effects. It is suitable for high flow, low resistance conditions. In addition, gate valves have good sealing performance. Under normal working conditions, they can effectively prevent fluid leakage. However, gate valves also have some disadvantages. Their opening and closing torque is large. Operation is labor-intensive, especially for large diameter valves. They require power assistance. Additionally, during frequent opening and closing, the wear between the gate and valve seat is significant. This can affect the valve's service life. Next, let's look at globe valves. Globe valves are also common in industrial pipelines. Their structure mainly includes a valve body, valve cover, valve disc, valve stem, and sealing components. The valve body is also the main part connecting the pipeline. The valve cover protects internal components. Unlike gate valves, the valve disc of a globe valve is disc-shaped. The valve stem is directly connected to the valve disc. The working principle of globe valves is to control the position of the valve disc through the up and down of the valve stem, thereby achieving the opening and closing of the valve. When the valve stem rises, the valve disc subsequently lifts, the fluid access opens, and the valve opens. When the valve stem descends, the valve disc presses against the valve seat, closing the fluid access, and the valve closes. The characteristics of globe valves are distinct. Their advantage is good sealing performance. They can effectively stop fluid flow. This makes them widely used in situations where high sealing performance is required. At the same time, Globe valves have good adjustable performance. They can precisely adjust fluid flow by controlling the opening of the valve disc. However, globe valves also have some drawbacks. Their fluid resistance is relatively high. This is because when fluid passes through a globe valve, it needs to change direction, increasing the flow resistance. In addition, globe valves have directional installation requirements. They must be installed according to the specified flow direction. Otherwise, it will affect the normal operation and service life of the valve. Finally, let's learn about ball valves. Ball valves are also the most common in chemical pipelines and widely used. The structure of ball valves mainly includes a valve body, ball, valve stem, and sealing setting. The valve body provides installation space for the ball. The ball is the key component of the ball valve. It has a circle-through hole in the middle for fluid flowing. The valve stem is connected to the ball. Rotating the valve stem drives the ball to rotate. The working principle of ball valves is that when the valve stem rotates 90 degrees, the through hole on the ball aligns with the pipeline axis. The valve opens, and fluid can flow freely. When the valve stem rotates another 90 degrees, the through hole on the ball becomes perpendicular to the pipeline axis. The valve closes and stops the fluid flowing. The advantages of ball valves include low fluid resistance, quick opening and closing, good sealing performance, and long service life. They have simple structure, small size, and lightweight. However, ball valves also have some limitations. Their manufacturing cost is relatively high, especially for high-precision, corrosion-resistant ball valves. In addition, when used for flow regulation, their precision is relatively low. They are not too suitable for situations requiring very precise flow regulation. Through today's learning, we have learned about the structures of gate valves, globe valves, ball valves, their working principles, and characteristics. In practical applications, we need to select the appropriate valve based on different working conditions. Choosing the right valve ensures the safe and stable operation of the pipeline system. That's all for today's lesson. Next, let's consolidate the knowledge we learned today through a few exercises.